Hi, welcome to our next trigonometry video. We are now turning our attention by using SOHCAHTOA to find an angle. Right, recap on the hypotenuse, opposite and adjacent sides, and a quick reminder of what the mnemonic SOHCAHTOA means. Right, straight into an example. Example 1. We're going to find the size of the angle theta. We're going to use the same 4 steps as we have in the last couple of videos, but there's a couple of differences. So let's go. Step 1, label the sides. We have the hypotenuse, we have the opposite, and we have the adjacent sides. Step 2, let's pick one of these rules, so, ka, or toa. Now it's a little bit different to the last time when we were trying to find a side because we know two sides of a triangle. We know the opposite and we know the hypotenuse. So the rule must have an O and an H in it. So in this example, it's the SOH rule. So here's our SOH triangle. We're up to step 3. We're about to substitute and solve. So the S means sine of the angle theta, but we don't know what theta is, so I can't put that into that section of the triangle. I do know O is 45, so I'm going to replace O with 45, and I do know my H is 70, so I'm going to replace H with 70. Right, well once again they're on top of each other, which clearly means we have to do a divide. But we don't just go 45 divides 70. We've got to do a special trick because we're trying to find an angle. And that trick is we're going to go sine to the minus 1 bracket 45 divides 70. Now the sine to the minus 1, we say sine, inverse sine is what it's called, the inverse sine. And we use inverse sine when we're trying to find an angle. Now, if you have a look in your calculator, how do I get sine to the minus 1 or inverse sine? I need to push shift and then let go of shift and then push my sine button, and it should bring up a sine to the negative 1, which is my inverse sine. So I'm going to go shift sine bracket 45 divide 70 close bracket. And that should give me an answer which is very close to 40.00520088, which I'm going to round to 40 degrees. Now the units are degrees because it's an angle, so we've just calculated the angle theta to be 40 degrees. Right, let's see if you understand it. Second time round. Find the size of the angle x. So we're not calling it theta, we're calling it x. All right, step 1, let's label sides. Here's the hypotenuse, here's the opposite, and here's the adjacent. Right, step 2, which rule are we going to use? So, ka, or toa. Now, because we're finding an angle, we know two sides. We need to know two sides to find an angle. So the first side is the opposite, and the second side is the adjacent. So the rule must have an O and an A in it, OA. So it must be my toa rule. Right, well here's my toa triangle, and we're up to step 3, substitute and solving. Remember the T in the bottom left means tan of the angle theta. No, we're not using theta, we're using x, so tan of x. But we don't know what x is, so we can't put that into that section of the... We can put 2.4 in for O, and we can put 2.3 in for the adjacent A. Once again, they're on top of each other, so we want to do a divide, but because we're finding an angle, we have to do the special trick, and it's the inverse tan. Tan to the negative 1 of 2.4 divided by 2.3. So we need our calculator. Remember, we're going to go shift tan, go shift, let go of shift, go tan, open up some brackets, 2.4 divide 2.3, close the brackets, and you should get an angle which we're going to round to 1 decimal place, which is 46.2 degrees. We've figured our angle x is 46.2 degrees. Right, takes a bit of practice this one. Go away and keep going until you're feeling really confident. Thanks for watching.